Hello, everyone. So you're welcome to this lecture series. This is going to cover the topic on introductory probability. In order to shorten the length of lectures, I'll make this a couple of videos for you. Okay. So we would cover, of course, some introductory stuff, and we'll start with classical probability. And then we'll look at some rules of probability and look at what is a complementary event. So after looking at classical probability, we move on to empirical probability. Look at the law of large numbers. And then most importantly, some addition and multiplication rules of probability. Okay, so that will be the outline. We'll probably cover a few of these, and then we'll move on to the other ones later on in the subsequent lectures. So probability, in general, you can think of it as the chance, right? The chance of some event occurring. Okay, so that is probability. The probability that it's going to rain, the probability that you'll come to the lecture. So what is the chance, really, that something will happen? That is what you can think about as probability. So there are a lot of examples in playing games of chance, card games, lotteries, and other important applications, not just in games. It covers fields in insurance, investments, even in weather forecasting. You apply theorems and theories in probability. So probability has a wide application in various areas. It is the basis for, inferential statistics. You have statistics. You want to infer something, make projections or predictions. It's often based on probability theory. Even hypothesis testing uses probability. And so probability is very important, and that is why we are covering it. You would need it at a point in time in your studies. Okay. So some of the basic things that you will come across in probability is probability experiments. What is a probability experiment? We'll look at that. We'll come across what a sample space is, sample spaces. And then again, we'll look at addition and multiplication rules. And then the probability of complementary events. Sometimes it's difficult to find the probability directly, but if you can find the probability of the complementary event, then it becomes easier to find the probability itself. Okay, so processes such as flipping a coin, rolling a die, drawing a card from a deck are called probability experiments. Okay, and this falls under classical probability. These were the first, if you like, events that were used to develop probability theory. And so we're going to start with them. So a probability experiment is, by definition, a chance process that leads to a well-defined result called an outcome. Okay, so you must have a defined outcome of your probability experiment, whether it's tossing a coin, flipping a coin, rolling a die, or whatever it is. You must get an outcome. And the outcome is the result of a single trial of a probability experiment. So if you just flip a coin once, what you get is the outcome. Okay, so you do the trial just once. The result of that is referred to as an outcome. Okay. And a trial, of course, means these examples: flipping a coin, rolling a die once, and so on. So when a coin is tossed, for example, there are two possible outcomes. You either get a head or a tail. Okay, so we are excluding the fact that it might be possible for the coin to land on its edge. So this is not part. We are assuming that it's going to land on the heads or tails. And then the roll of a die, there are 6 possible outcomes. If you roll a die, you gotta get a 1, 2, 3, 4, 5, or a 6. These are the 6 possible outcomes when you roll a single die. Okay, So in any experiments, the set of all the possible outcomes is called the sample space. And this is very important. We'll use the sample space later on to be able to compute probabilities. Right now, we are just defining some of the simple concepts that we'll come across. Okay, so being able to determine the sample space of an experiment is important, especially under classical probability. Okay, so the sample space, by definition, is a set of all possible outcomes of a probability experiments. We'll look at some examples. Okay. So if you toss a coin once, the sample space will be head or tail. So there are basically two elements in the sample space, head and then tail. If you roll a die, the elements in the sample space will be these numbers, right? 1, 2, 3, 4, 5, and 6. If you answer a true or false question, the sample space will be true or false. Toss two coins, the results will be head. In other words, the first coin will be head, the second will also be head, or tail. Both will be tails and tails. Or you could have a head tail. The first coin shows you a head, the second a tail, or the first gives you a tail and the second a head, TH. Okay, so HH, TT, HT, and TH here will be the sample space when you toss two coins. All right, so this will be the outcome of a single trial. You just toss two coins at once. These are the possible outcomes, and all the outcomes then forms what you call the sample space. Okay. Well, the sample space when you roll two dice. Okay, just roll two dice. One way to find the sample space is what is displayed here. Okay, so die 1 has 1 to 6 on it. Die 2 has 1 to 6 on its faces. So each of these combinations is possible when you roll two dice. So you could get a 1-1 or 1-2, right? In other words, die 1 shows 1, die 2 also shows 1, or die 1 shows 1, die 2 shows 2, and so on. Okay, so that gives you the sample space. So you have 36 elements when this experiment is carried out. All right. Okay. And then the other ones that you would see, again, these examples will come across them. So it's important to know some of these experiments. We'll use them to solve problems of computing probabilities. So it's important to know the outcomes of all these classical experiments that are done. You know, rolling a die, tossing a coin, and so on. The other classical one that you will see is when you draw a card from an ordinary deck. Okay, so an ordinary deck, by ordinary deck, we mean a deck where you have 4 seats, hearts, clubs, diamonds, and spades. All right, so these are our diamonds. We have the clubs, we have the these are the spades, sorry, clubs, diamonds, and hearts. All right, so there are 4 seats, and then each of these have 13 cards. So if you take the spades, there are 13. You have the ace, and then you have 2 all the way to 10, and then you have a jack, you have a queen, and then you have a king. Okay, so each of the suits have these. All right, which means that you're going to have 4 jacks in their card. There are 4 queens, and then they have 4 kings. All right, and 4 aces. So it's important to know some of these because we'll be using them later on to solve problems. So in all, 13 times 4, you have 52 outcomes in the sample space when you draw a card. Just draw one card, you can draw any of these. Okay, and then let's look at this other one. Another example is the sample space for the gender of the children. If a family has 3 children, okay, what is the sample space? Well, if they have 3 children, let's call the boys B and the girl G. Okay, so there are 2 genders, male and female. And each of the children could be either gender, could be a boy or girl. So by observation and of course by reasoning, if you have 3 children, these are the possible outcomes. And so all the possible outcomes then give us our sample space. We could have all 3 being boys, and then 2 boys and then a girl. We could have, 1 boy, 2 girls, and so on. Okay, so note that the order is important here, right? So even though we have 2 boys and a girl, 2 boys and a girl here, the order is different. 2 boys come, the first born is a boy, second born is a boy, third born a girl. Whereas here, the first born is a girl, second is a boy, the third is a boy. All right, so all of these combinations make up the sample space. Okay, so sometimes you can use what is called a tree diagram to get these combinations. I'll show you a tree diagram. So this is a tree diagram, right? So first child could be boy or girl. Okay, the first child is a boy, the second could also be a boy or girl. So we have that. And if the first was a girl, you could have these combinations. So all these combinations after here, you can get the outcomes. So boy, boy, boy gives you this. Boy, boy, girl gives you BBG, and so on. That gives you the sample space, okay, all the outcomes. All right, so these are classical examples that you'll find under an introduction to probability, okay? So remember that the outcome is a result of just a single trial of a probability experiment. But in many problems, you will do the experiment several times, right? So you could have 2 or more outcomes. So we distinguish between what an outcome is and what an event is. An event constitutes 2 or more outcomes, all right? So not just a single experiment. So an event consists of the outcomes of a probability experiment, all right? So this could be done, 2 or more times, not just 1. So that's one of the big differences. Okay, good. So this is just explaining the same thing. Okay, an event with 1 outcome is a simple event. An event, for example, of getting an odd number when a die is rolled is called a compound event. All right, since it consists of 3 outcomes or 3 simple events. All right, to get an outcome, you may not get it the first time. You have to do it a couple of times to get that. Okay, so in general, a compound event consists of 2 or more outcomes or 2 or more simple events. Okay, good. So this is just introduction. So the 3 basic types of probability that we'll see are classical probability, and then we'll have empirical, or relative frequency probability, and then we have what is called subjective probability. Okay, so we'll focus mainly on the first 2. Subjective probability really has to do with the probability based on some educated guess or some estimates that you make based on experience, based on opinions of other people. So it's based on inexactive information. All right. So based on my experience in teaching the course in calculus, I can tell you the number or the percentage of students will pass, percentage will fail. That is subjective, right? Okay. So we will not dwell much on this. We'll start by looking at the classical probability, and then after looking at the classical probability, which is classical, I'll show you because it is the first type of probability that was looked at, and from which other probability theorems and techniques have been developed. And then later on, we'll look at empirical probability, where you can actually gather data, right? Either yourself or somebody gathers data, and then you can use that to compute probabilities. Okay, good. So I'll end this one here. In the next lecture, we'll start with classical probability, look at some probability rules, and then we'll look at complementary events. That's what we're going to start by looking at. All right.